My name is Advika.
My name is Sai.
My name is Lucky.
My name is Ron.
I'm Gagi, and we are Group 76, and we have decided to choose Task D for our assignment, which is about hotel pricing decisions. Hotels need to make critical decisions to run their hospitality business. They need to balance profitability while also maintaining a positive reputation and keeping up with demands. So, our group has decided to look at hotel prices and understanding how room prices can be influenced by several factors to help balance affordability and create revenue. Using a dataset taken from 300 hotels, our aim is to investigate how factors like location, rating, costs, and affiliation can influence our dependent variable average room price, and find out which variables have the strongest relationship with it. Research from eHotelier shows the five main factors that influence room prices are location, state of economy, technology, cleanliness, and the type of room, with hotels closer to tourist areas and luxurious rooms charging more. The analysis is useful as it helps identify how key factors can influence room pricing so hotel managers can make smarter decisions by understanding the relationship between them. By using the regression models, we are able to evaluate how strong each relationship by applying a real world scenario to improve strategic planning.
Building on those industry drivers, our research firm operationalized these factors by analyzing a specific dataset of 300 Australian hotels. Our data represents a 1 month performance snapshot across the major capital cities shown on our map. To ensure a comprehensive view, we used a dual source approach, combining internal booking records with public customer reviews. Our primary focus is the dependent variable average room price. Project D was intentionally provided as a messy data file, which wasn't ready for analysis. To ensure our results were statistically valid, we had to resolve conflicts within the dataset to provide a clean foundation for the group's analysis. The first step was to find the profit variable. In the raw data, we were given revenue and operating costs as separate entities. However, in the hotel industry, a hotel could have high revenues but even higher costs, leading to a loss. So, by applying the equation revenue minus operating costs equals profit, we created a much more useful predictor. Next, we addressed the qualitative data through a process called dummy coding. Our dataset included the chain affiliation variable, which is either chain or independent. Because regression models are mathematical equations, they cannot process words. We transformed these labels into a binary format, assigning a 1 for chain and a 0 for independent. This step was crucial as we could see how many dollars a brand name adds to or subtracts from a room's price. The most challenging part in our methodology was defining a hotel type. This variable is a classification based on both service level and price segment. However, during our initial audit, we noticed that some hotels had luxury prices, which would be considered as 3 points, but budget ratings, which would in our case be considered as 1 point, making them difficult to categorize under a single label. So we developed a composite point system, which is shown in this table. We assign points on a scale of 1 to 3 for both room price and customer ratings. So as you can see, a price under $200 earned 1 point, while a rating over 4 stars earned 3 points. By totaling these together, we created a weighted classification. A total of 2 to 3 points defined a budget hotel, 4 to 5 points defined mid-scale, and only a perfect 6 point was classified as luxury. For our statistical analysis, our group used multiple linear regression as our primary tool. We chose this method because hotel pricing is influenced by a wide variety of factors at once. To find the most accurate drivers of price, each member of our group tested different sets of variables. Our group strategy was standardized. Each member built 2 models, each containing 3 unique predictors. We then compared these models using the adjusted R-square to see which one explained the most variation in price and analyzed the p-values to ensure our results were statistically significant. This process allowed us to eliminate the weaker models and identify the specific factors that truly dictate room rates in the Australian market.
Our dataset consisted of both numerical and categorical variables, and in order to individually analyze them and pick them for our models, we used different analytical techniques. So only numerical predictors could be used effectively in a correlation matrix. And as you can see, we've got a heat map style matrix on the screen there. We wanted to see which factors were the most strongly associated with average room price. From the matrix, the standout predictor is revenue. However, we decided that revenue was more of an outcome of average room price as opposed to an explanatory factor in the price of the rooms, so we excluded it from our models. We also excluded profits for the same reason. We were interested in customer rating, which showed a moderate relationship with the average room price. Unlike revenue, the relationship wasn't as clearly defined, which made it an interesting variable for further analysis. We chose it over operating costs, which had a similar correlation coefficient, because our investigation is more focused on market factors as opposed to the business and operating side of running hotels. So to analyze the remaining categorical variables, we created box and whisker plots to compare distributions across individual categories in each predictor. What we saw is that chain affiliation and city had relatively stable medians across each of their respective categories. However, we still selected city for one model as it allowed for comparison with tourist zone. Tourist zone was the first categorical predictor with interesting results. Waterfront hotels had a much higher median and mean than the other categories. The median room price of a waterfront hotel was around $200 higher than the other locations, which suggested a strong location-based effect on the average room price. Hotel type was another predictor that had clear separation between categories. As the quality of the hotel increased, so did the average price of a room. This seems logical and straightforward. However, we still included it in the regression model to see how it interacted with the other variables.
For our initial base case model, we decided to explore the influence of tourist zone, city, and chain affiliation on average room price. We expect some cities, such as Melbourne and Sydney, and some tourist zones, such as Waterfront and CBD, to have higher average room prices due to these places being more popular for locals and for tourists. We began by using dummy coding, using the method that was described earlier, to come up with our base case. And our reference case for these results is a suburban hotel that is found in Melbourne and runs independently. For our initial base case model, we decided to explore. The most interesting finding is the influence of the waterfront location on average room price. As you can see from the bar chart, hotels on the waterfront are able to charge an extra $239 premium over our base case of suburban hotels. This amount is also significantly higher than all of the other micro-locations within our capital cities, showing that this micro-location plays a key role in determining average hotel room price. Logically, this does make sense, as waterfront hotels are likely to be perceived as a greater luxury in Australia, where most capital cities are located near the coast anyways. Additionally, waterfront hotels also have an extremely low p-value, as you can see on the table in the green, which allows us to confidently reject the null hypothesis that location does not influence average room price, as we can see that it does in fact influence. From a pricing decision standpoint for any hotel managers, this suggests that a micro-location of a hotel is a valuable asset and greatly influences average hotel room price. However, what's just as interesting to note is what didn't influence. We expected city to play a key role in also influencing average room price. However, as the table on the right shows, all the p-values for our cities were not statistically significant. Consequently, in every single one of these cases, we failed to reject the null hypothesis. This means that there is no statistically significant difference between the prices in these cities in comparison to our base city of Melbourne. What this model ultimately reveals is that the micro-location within a capital city plays a more pivotal role in influencing hotel room price over the actual capital city it is located in. This means that a waterfront hotel anywhere, whether it be in Sydney, Brisbane, or Perth, is able to charge a greater premium just for the fact that it's located near the water, over the fact that it's whatever city it is actually located in. This shows for future investors and developers that a hotel near the waterfront in Perth over a hotel in the suburb or in the CBD in Sydney is still a better investment and is likely to have a greater average room price.
All right, moving on to our second model, which we chose to investigate further. This model uses hotel type, customer rating, and tourist zones as its predictors. We start with the assumption that a hotel's class, whether budget or luxury, acts as a primary price floor. a baseline, if you will. The tourist zone dictates the demand premium. Finally, we looked at customer rating as a measure of the perceived quality of this hotel. The goal of this model is to look beyond measuring these factors in isolation and instead determine how they interact with one another to define a hotel's competitive pricing strategy as well as the ultimate market value, by which I mean the average room price. So, to analyze model 2, we decided to create a regression table. So in this, we found that our second model actually yielded a strong adjusted R-squared score of 0.759, proving that location, hotel type, and ratings account for nearly 76% of average room price variation. It should be noted, however, that airport and budget were chosen as baselines, as they were found to have the lowest average room price categorically. While most predictors were actually highly significant, the value greater than 0.05, the suburban zone was actually a notable outlier, with a p-value of 0.41. This suggests that suburban pricing doesn't actually deviate enough from our airport baseline to be a distinct predictor. The most compelling insight, however, is the rating paradox. Despite luxury hotel types and waterfront locations commanding premiums of roughly $200, we find a negative coefficient for customer ratings. This actually indicates that for every 1 point rating increase, price actually drops by $16, suggesting that in this specific market, high-value budget hotels are actually outperforming the expensive luxury ones in terms of customer satisfaction. To understand the why behind our pricing, we decided to analyze the relationship between hotel types and their chosen location. As shown in the left-hand side graph, our dataset reveals that mid-scale hotels dominate the market through maximum distribution, particularly in the CBD. Conversely, luxury hotels follow a much narrower strategy, clustering almost exclusively on waterfront areas to really anchor their brand prestige. When we cross-reference this with the average room prices on the right, the structural reasons for our regression coefficients becomes very clear. You'll notice a total absence of luxury in the airport and suburban areas. This proves that these specific locations really weren't suitable to support such a high-end business model, effectively capping the prices at these locations. Finally, the data shows a clear waterfront premium. Even a budget tier hotel on the waterfront commands a higher price than a mid-scale hotel in any other location. This really validates our earlier finding that location isn't just a variable, it acts like a multiplier that allows even lower tier hotels to drive much higher average room prices. The most counterintuitive finding in our regression is actually the negative 16.56 coefficient for customer ratings. While this sounds like quality isn't being rewarded, our scatter plot actually helps us see the true story. If we look at the red circle, we see a massive cluster of high volume but lower priced hotels. These budget and mid-scale options maintain very consistent 4 to 5-star ratings because they hit their value proposition perfectly. Customers have more realistic expectations and are more frequently satisfied by what they experience at this more affordable pricing. However, as prices increase towards $600, the data becomes much more volatile. We can see this through the high price sensitivity outliers in the bottom right. This proves that high-paying customers are a lot more stringent when it comes to their expectations. A single service failure at a luxury price point results in a much more punitive lower rating, which creates this downward mathematical pull, which we see in our regression model as a negative coefficient.
We found that the strongest relationship with hotel room pricing were tourist zones, hotel type, and customer rating, while the second strongest relationship was tourist zones, city, and chain affiliation. This suggests that both the location and reputation of a hotel play a major role in determining how much hotels are able to charge per room. In comparison, weaker factors included staff count, operating costs, and rooms booked, indicating that these variables may have a less influence on pricing decisions. Practically speaking, these results suggest that the hotel managers should focus on improving customer satisfaction and maintaining strong review ratings, as higher rated hotels appear to have a greater ability to support increased room prices. Additionally, choosing locations in popular tourist zones may provide hotels with a stronger pricing power and improved competitiveness within the hospitality market. One limitation is using different base factors when making regression models, which may affect the R-square value, leading to different results. Additionally, the regression model demonstrates relationship between variables and does not consider other variables that may affect the results but are not shown in the dataset. A recommendation would be to extend the data collection period from 1 month to a year, as this may capture seasonal trends and fluctuations in the hotel's performance, leading to a more accurate and reliable result. Further studies could also include additional variables such as occupancy rate, hotel star rating, and competitor pricing to improve the predictive ability of a regression model.